Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in geometry, part B, lesson 12, and we're going to talk about the distance formula. Let's take a look at what we have to do here. So here is a couple of examples, like first part of like 11 through 20. And what it just says is find the distance between the following points. So you've got 2 points. So here we've got 3, -2, and 7, -3. Now, don't try to graph these. You could do it, but you'd have to use Pythagorean theorem. But the Pythagorean theorem breaks down into the distance formula. So let's take a look at the distance formula and how to use it. So here is what the distance formula is. It is the square root of the x values, so x1 minus x2 squared, plus the difference of the y values squared. So x1, y1, x2, y2. And just plug those in. So we're going to plug in the x's. So we've got the square root of 3 minus 7 squared plus -2 minus -3 squared. All right, so we're going to simplify this. 3 minus 7 is -4. So we've got the square root of -4 squared plus, and here we're going to have to use keep, change. We've got -2 plus 3, which is 1 squared. So now we're going to simplify a little more. We've got -4 squared. Now, I've got my calculator here because I want you to pay attention to this very closely. There's a big difference between this, -4 squared, which is going to give you -16. And if we put it in parentheses and do -4 squared, this is what you need to do because it'll give you positive. Anytime you square a negative number, it's going to be positive. So don't forget your parentheses if you're trying to use it on a calculator. So -4 squared is 16. We've got the square root of 16 plus 1, which is the square root of 17, which is the final answer. Now, if you want to, you can find the square root of 17 on your calculator, but you don't really need to. So this is approximately 4.1. But I would leave it as the square root of 17. So that's how you apply the distance formula. All right, let's take a look at our next example. We're going to find the distance between these 2 points. Again, we're going to apply the distance formula. The distance formula is the difference of the x's squared plus the difference of the y squared, all under the radical. So again, x1, y1, x2, y2. So the x's, 6 minus 1 squared plus the y's, -8 minus 4 squared. 6 minus 1 is 5, so that's 5 squared, plus -8 minus 4 is -12 squared. Keep simplifying. So we've got the square root of 5 squared, which is 25, plus 12 squared, -12 squared, which is 144. And that's going to equal the square root of 169, which we want to check all of these to see if they're perfect square roots. This happens to be a perfect square root that I know. If you're not sure, just plug it in. It turns out to be a perfect square root. Write that as your answer. So that would be the answer I'd want on this one. So that's the distance formula. All right. Now, the last few in the lesson Say find the radius of the circle with the given center, C, that passes through the given point, Z. So basically what that means is that in the coordinate plane, you've got a point somewhere, that's the center, and you've got a point Z somewhere that's on the circle, and that's going to be the circle. So we want to find the distance from there to there. That's the radius. Guess what? It's still the distance formula. So we're still going to apply this distance formula. X1 minus x2 squared plus y1 minus y2 squared. X1, y1, x2, y2. So we've got the square root. -5 minus -4 squared plus, that's parenthesis right there, Mr. Rowe, pay attention. Okay, and then plus the differences of the y squared, so we got -3 minus -5 squared. -5 minus -4. If you're not sure about this subtraction, don't be afraid to use this calculator. -5 minus -4 should be -1. So we've got -1 squared. And then we've got -3 minus -5. Again, don't be afraid. -3 minus -5. And that's 2. So plus 2 squared. And so we've got negative, oops, excuse me. We've got -1 squared, which is 1, plus 2 squared, which is 4. And this will equal the square root of 5. Square root of 5 is not a perfect square, so just leave the answer just like that. So that's how you apply the distance formula. This is the Cartesian plane. That's basically all it is. So I hope this helps you get through this lesson. If you're still struggling with the content, please let me know in a teacher message or make that appointment for a help session.